So good evening, everyone, and this is your lecture number 8. And I think we need to start with your electric flux and your Gauss law. In the previous class, we had seen that area is treated as a vector quantity. For closed surface, we had seen that the direction of this area vector is taken perpendicular to the surface. For open surface, it can be taken as any normal. Remember this closed surface and open surface, because these are going to come a lot of time in this particular chapter. When I say a closed surface, it's a surface that encloses a volume. And when I say an open surface, it means it does not enclose a volume. Anything that is open is an open surface. Now, as soon as we move on to the term electric flux, what do you mean by the flux of any field? Now, this flux is defined for any field which is a vector field. So it would be gravitational flux as well. It could be magnetic flux as well, because magnetic field is also electric vector field. So this flux is always defined for a vector field. What do you mean by electric flux? It's defined by the letter phi, electric flux phi. Yes, what do you understand by the word electric flux? Hmm. What do you mean by electric flux? Anyone? Any idea?
Number of electric lines of force crossing the area perpendicular.
It is the correct.
Number
What you are
of
saying is correct. It is the number of
electric lines of force
electric lines of force, or I can say EFL, electric field lines, or lines of electric force. Yes, numbers of electric field lines
crossing the area perpendicular.
crossing the area in a direction perpendicular to it. What do you mean by in a direction perpendicular to it? Crossing the surface in a direction which is perpendicular to it. When I say this perpendicular direction, it actually means the direction of the area vector. So number of electric field lines crossing the surface in a direction perpendicular to it is known as your electric flux. Now, if this is a small area, small segment, we can draw its ds vector. Do you understand what is this ds vector? Huh?
Yes, sir.
This ds vector is the area vector of this surface, and this surface could be placed in an electric field. An electric field not necessarily will go in the same direction as the area vector. It can go in any direction. Now, how do I find out the small flux or the number of electric field lines which are passing through this surface? I find it like this: d phi, the small electric flux, will be E dot ds. It is the dot product of E with gs, or the total flux passing through this area will be the integral of E dot ds. And that is how we write it. The total number of electric field lines which are passing through a surface. We will have electric flux, we will have magnetic flux, we can also have gravitational flux. Though gravitational flux may not be a part of your course. E dot ds. This is how you find out the electric flux through any surface. Now, as I said, that the surface here that we are dealing with may be of two types. So when I write it like this actually refers to the flux through an open surface. This actually refers to the flux through an open surface. If I have to write the formula for flux through a closed surface, the formula I should correctly write it like this: flux through a closed surface, and it will be written like this. It should be written like this. Then we say that this is a flux through a closed surface. This symbol gola on the integral tells us that it is the integral on a closed surface. So this is how it is written for a closed surface. Now this is how it is written in maths, because this is mathematical term. We'll have to also try to speak it in a common language. So how do I define the flux in a common language? Flux through any surface will be defined as what? It is the integral of E dot ds, but the way we call it will be slightly like flux through any surface, whether it's a closed surface is the surface integral. It is the surface integral of electric field. If it is closed surface, the surface integral is done over a closed surface. If it is an open surface, the surface integral is done over an open surface. So this is how we speak it. There are two types of integral of electric field that we'll have to encounter. This one is the surface integral. We'll also have one more integral coming up, line integral. This is surface integral. What do you mean by surface integral? This is a surface. This one is a closed surface. You are integrating the surface. That is a surface integral. You are integrating the surface. Whether it's a closed surface or it's an open surface, integral when done over surface is known as surface integral. Then there is one more integral which is known as line integral. The integral is done on a line. You take a line and you integrate it. Tick, 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 tick. This is the line integral. This is the surface integral. Anyways, so flux through any closed surface, or flux through any surface is the surface integral. If it is a closed surface, you will write gola so that you understand it's a closed surface. If it's an open surface, you will just write the integral. What type of quantity is flux? Electric flux or magnetic flux or gravitational flux? What type of quantity is electric or gravitational flux? Huh?
Vector. Scalars.
It's a scalar quantity. It's a scalar quantity. The SI unit. What is the SI unit?
Newton meter square by coulomb.
SI unit, you can call it as voltmeter, or you can call it Newton coulomb per meter square, I think. Newton coulomb per meter square. Do we understand this?
Yes, sir.
Yes, sir.
Now, if number of electric field lines, so basically electric flux is the measure of the number of electric field lines which are crossing the surface in a direction perpendicular to the surface. Now, up till now, we have not used electric flux. Up till now, we have used electric field or electric field intensity. Now, how do you define the electric field or electric field intensity in terms of the number of field lines? So now we can also understand this. Electric field intensity, or the intensity of electric field, which we were calling it as electric field E.
Sir, it is Newton meter square by coulomb, na sir.
Is Newton meter square by coulomb? Okay.
It's a unit, sir.
Pakka?
Paka, sir.
Okay, sir. I write it, sir. I was just checking you. Okay. Electric field intensity, E vector, the thing that we were writing is as electric field or electric field intensity. The number of field lines which are passing through the surface is flux. Then what is electric field intensity? How will I define the electric field intensity then? The total number of field lines which are passing through a surface is electric field intensity. Is electric field, then what is electric field intensity? It is a
The
number of
field over
say. It is a number of electric field lines passing per unit area. So when you find out the electric field intensity, this word intensity, do you recollect this word intensity from your previous knowledge? Intensity? Did you hear this term intensity before?
Yes, sir.
Where?
Wave optics.
Wave optics.
And
Intensity was
also
intensity
wood
was
electric arc.
intensity was energy falling per unit area per unit time. Do you remember it?
Yes, sir.
Here it is number of field lines per unit area. Time does not come. Okay, so this is the electric field intensity. Your original electric field, it is the number of electric field lines per unit area. Therefore, it is intensity. Okay, so this is what we know. Now, this electric flux is our concern because electric field we are already done. Now, this flux is a scalar quantity. Now, if it is a scalar quantity, electric flux is a scalar quantity. Let us move back to electric flux. I just had to tell you electric field, so I took it here. Now, let us move on back to electric flux. Now, electric flux is a scalar quantity. Now, if it is a scalar quantity, now the scalar quantity can be positive, it can be negative, and it can be zero. Because it's a scalar, it's a number, it can be positive, it can be negative, it can be zero. What determines whether it is positive or negative or zero? Now, we have written flux as integral of E dot ds. Now, if electric field is constant and your area angle is not changing and all that, if this electric field and the angle theta is constant, let me write it more perfectly. If this angle theta is constant, I can write this electric field, the flux, as E dot delta S, where delta S is your area, and I can write it as E into delta S, the area, multiplied by cos theta. Remember, it is subjected to the condition that electric field is constant and your area vector and electric field ke beech ka angle is also same. If the angle changes, then the problem comes. But if the area and angle and everything is constant, I can write this flux as E into delta S into cos theta, and that will be the case in majority of the cases. Electric field and area vector will be constant. The angle will be constant unless and until we come to different questions. Now, what decides whether this flux is positive or negative or zero?
Theta.
This theta determines whether this flux is positive or negative or zero. When will it be positive? When it will be negative? When will it be zero?
If theta is acute angle, then it is positive.
If theta is acute angle, then it is positive. Well done. Then
Theta is obtuse angle, then it is negative.
when theta is obtuse angle, it is negative. And then third one,
Theta is 90 degrees.
when it is perpendicular, area and your field area vector and your field is perpendicular, right angles, then your flux can also be zero. Even though there is electric field, even though there is area vector, your flux can still be zero if the angle between, what? If the angle between electric field and your area vector is zero. Do we understand this?
Yes, sir.
And this case is illustrated here in this diagram. You can see it for yourself. Let me put it here. If I can, no, I cannot in this way. So I'll have to put it this way. So you can see this case where this electric field is parallel to your area vector, and you will see that the flux in that case would turn out to be positive. I hope you can see this. Case number one, the flux is turning out to be positive in this case, and it will be simply equal to E into S, or E into area, or E into delta S, where E is the magnitude of electric field or the intensity of electric field, and delta S or A is the area. You just take the magnitude because it's a scalar quantity. You are taking the dot product, so you can do it. You can do the thing with the magnitude. If the area vector, if area is like this and electric field lines are going like this, area vector and electric field lines will make an angle of 90 degrees. In that case, even though there would be electric field and area, the flux would be zero. I hope everyone understands this. Most of the questions that you are going to encounter would be based on this concept of finding out the relation between electric field and this and that. Electric field is given, area vector is given, you will have to find out the flux and all. I'll give you 1 minute to note it down. Once you have done it, please let me know, bacha, so that I can move ahead. Remember, what the questions that you are going to get in a JEE would be very simple. So just remember simple things in this. If you remember simple things, you will find out the same question that we are doing will come in the exam. But you just have to remember simple things. Don't do it quickly. Don't do it in a haste. Remember simple things. And I told your NEET wala students also, you don't have to write everything in the same language that I am writing here. Just understand it and write it in your language better, because at the end of the day, it's for you to understand. And if you don't understand it, sometimes what I'm speaking and what I'm writing, I may be just using a shortcut. I may not be writing the full sentence. If you also do the same thing, you will forget what I was actually saying, what I actually meant, because I have only done half of the sentence. Here, for example, if I tell you, I have only written half of the sentence here. See, I have not written the full sentence. Number of electric field lines crossing the surface in a direction perpendicular. Perpendicular to what? I have not written it here. It's perpendicular to area. Do we understand this? So sometimes while I'm writing, I may be missing one or things just because I am saying it. But if you are writing the exact same thing that I am saying, the exact same thing that you see on the board, then there might be one or two words that I have missed or you have missed. Once you read it, you will not be able to understand what it means. So understand, that's why I speak a lot. Understand it and write it in your own language. I might be missing a word or two. I don't do it knowingly, unknowingly sometimes it happens. But yeah, I make sure that I don't miss the important words. Sometimes, yeah, I might miss a word. You will have to remember it. Do you understand what I'm saying, beta?
Yes,
So
sir.
more important than your writing is your understanding, and then writing it in whatever language that you understand. Okay. There's no point of just copying from the board, because copying from the board will not make you understand this thing. Okay, so just remember this and let me know once you are done so that I can move ahead.
Done, sir.
Done?
Yes, sir.
Okay, boys, you have done?
No, sir.
No, sir.
Write it, write it. There is no haste. We are not competing. We are on track. We are not behind the course schedule. We will be completing your course in due time, even before that probably. We don't have to rush on to anything. Do it aram se, not a problem. If you noted it down, please let me know better. You have to understand it rather than noting it down. Understand it, write in your language. That's it. Trust me, we are well on course of doing good things. It's no haste. I was worried when we were stuck in optics. That is the time when I was worried. How will I get your course completed? Now I'm not. I know that we are on track.
Done,
Don't
sir.
worry. Done? Okay. So now going ahead, again, remember, try and understand it. That is more important. Now let me just draw a simple diagram, and that will illustrate the point more clearly. Always draw this diagram just to drive home a point. If I have my electric field along this direction, let me say that this is the direction I have my electric field. Now when I say that the flux is positive, now also try to understand the meaning of what flux positive means. Your area vector could be here, ds, or it could be in this zone, or I should say, if I talk quadrant wise, if your area is in this green quadrant, when I say this green quadrant, that means your first and the fourth quadrant, your flux would be positive. Do we understand this?
Yes, sir.
Flux would be positive. Now whenever you talk about positive flux, that actually means that area vector and electric field are having acute angles. That means the flux is going out. So positive flux actually means flux which is going out of something. This is the green zone, positive flux. Positive flux means outgoing flux. Positive flux means outgoing flux. Now, if you had your area vector like this, remember the electric field is still there. Your area vector is like this or like this. In the second and the third quadrants, I will call them the pink quadrants. If they were in the pink quadrants, your flux is going to be negative. Do we understand this? These quadrants, pink quadrants. The flux is going to be negative here. By negative flux, I mean my area vector is like this and flux is coming like this, ding, ding, ding. So this is incoming. This is incoming. This is coming towards me. My area vector is like this. This is coming towards me. So this is my incoming flux. Incoming flux is taken as negative, incoming. And if you had your area vector like this, ding, 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 ds, or ding, 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 like this. In this case, the angle is definitely 90, no choices, and the flux in this case would be 0. Incoming, outgoing. To make you understand this incoming and outgoing stuff, I think I have a small diagram. Incoming and outgoing, and it is easy. It is good for you to understand because after some time these charges will come and then you will understand what is an outgoing flux and what is an incoming flux. As you can see, this is an outgoing flux. And remember, this outgoing and incoming are only defined when the body is closed. The body is open, there is no outgoing and no incoming. When the body is closed, this is your outgoing. This is your outgoing. And that one is your incoming. This is your incoming. Do you understand this? Outgoing flux, incoming flux. Don't have to draw everything, just have to understand it. That this is outgoing, this is incoming. I'll give you 2 minutes. Let me know once you're done.
Done, sir.
Boys? Girls are faster, I understand. Good. But everyone does not have the same speed. Some of students like me are slow. Doesn't matter.
Sir.
Done?
Yes, sir.
Okay. So we have understood the meaning of outgoing and incoming. Let us move ahead and solve a problem first, and then we will come back and see more things. Let me, if I have a problem here somewhere. Yes, I have a problem here straight away. And you can do this problem without understanding any more stuff. The electric field in a region is given by this one. This is, remember, a constant electric field. You don't need to tell me the exact value because it will just require calculation. I just want to know the answer, how you're going to get this. The electric field is given by this vector, and you have a rectangular surface of area 0.2 meters square parallel to the YZ plane. You have to tell me what is the flux passing through this. Now remember, it's not given that in which direction the area vector is. So you can assume any direction, incoming or outgoing, and tell me the value of flux. I'll give you 2 minutes to do this.
Newton meter square by Coulomb, sir.
Now, I have the answer as well. Anyone got the answer? Boys are still struggling.
240, sir.
240. So how are you supposed to do this?
X is equal to E dot A, sir.
electric field is constant, the angle is same, so you can just take the dot product E dot delta A or delta S. You just take the dot product. And how do I take the dot product? It is 3 by 5 E naught I plus 4 by 5 E naught J, and I have to take the dot. How will I write the area as dot? How do I write the area as a vector here? The area is parallel to YZ plane. This is the YZ plane.
Yep, sir.
So the area vector could be along positive x-axis. The area vector could be along negative x-axis. It is not given, so I will just take one direction. So I will take it as positive 0.2 I, and I just take the dot product. To take the dot product, remember only this will get dotted with this because the rest of the thing is 0. You can take the dot product, get the answer, and stay happy. Everyone got this?
Yes, sir.
So it was quite simple. As you can see, all the questions related to flux are so simple. If you just understand the concept, and you would be doing good. This one, the diagram is not given, and I don't want to, and I don't wish to give the diagram as well. What is the flux through this? Yes, do we have an answer, bacha? Huh? Got trapped? Girls, my favorite. Do we have any answer, beta? Boys, my not so favorite. Do we have any answer? I'm just joking, and I value both boys and girls equally. Everyone is equal in the eyes of God and mine. That doesn't mean I'm God. Yes? Huh? No one has the answer? Do you want a hint? Everyone wants a hint.
L by 4 epsilon 1.
Huh? This is the hint. When the hint comes on your screen. Now, this is the hint. So good hint I have given. And after this hint, revolutionary hint, you have 1 minute to give me the answer after this hint. And your 1 minute is getting faster. It's going to go fast. No one has answer. Remember, When I teach you, I only give you questions from the portion that I have taught. That is the second hint. So whatever I have taught you just now, the question that is there on your screen only uses whatever I have taught you. And you should be able to do that question without any help. And that is why this question is given. If you needed any help, I would have given it to you beforehand. So you don't need any help to do this. You can do this from the information that I've already given to you. So that is the second or third or fourth or whatever hint it is. Apart from the revolutionary diagram that I've drawn. Yes, I still wait. And the answer is
0.
0. 0 is the hero here. 0 is the answer here. Why is the answer 0? Huh? Why is the answer 0? That is the next question. Akkad bakkad Bombay wo. Since we don't understand, so we'll mark 0. Whenever, so I have seen people who give this sort of tricks on the so-called YouTube channels. If there is an option which is 0, mark it. Because more often or not, 0 would be the answer. Let's see, I can't give you that logic. There's a logic behind it. There's definitely a logic behind it, and that is why the answer is 0. Yes, who is going to tell me that logic? See, this gentleman, this charge lies in the plane of that square, bacha. So even if I draw any type of electric field, the electric field lines that are going to cross this gentleman square. Area 0? Huh? Area is not 0. The electric field lines which are going to move will be along the surface of that square. The angle, perpendicular angle will be 0. So. If this is your square, the charge is placed here. The charge is placed here. Now, this charge is going to create field in all the possible directions. But what electric field lines are passing through this surface are going to flow along this surface. Yes or no? And the area vector of this surface, the area vector of this surface goes like this. And electric field line go ding, 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 ding like this. So the angle is 90. Flux is 0. So you did not have to think much because the answer was already there with you. Yes or no?
Sir.
Gone about that. Bye-bye. Bye-bye or no bye-bye? You understand this?
We understand this, sir.
Okay. So that was the answer for this one. The flux is definitely going to be 0. It's going to be 0. Now I was looking for it. Let me see if I have that question. I made a question in my head, and let me see if I get a diagram for that question. And this is not correct. This one, it here, this one. Chalo. So I made a diagram, make it a question in my head, and then I was looking for a diagram, and I got a diagram as well. Now we'll solve this question differently, but right now let us remember what I have told you is what I have told you, and you can do this question. This is you understand what is this? This is half of the hemisphere, half of the hemisphere, half of the sphere, hemisphere. And we have this gentleman charge plus Q standing at the center of this tongue, the center of this. The radius of this sphere happens to be R. Now you can see two types of surfaces here, and I shall color them. I like coloring. So one surface is this circular surface. I'm getting better at coloring. So one surface is this pink surface, which is one surface is this pink surface, which is known as the circular part. The other surface is this green surface, which is known as the, and I like coloring. So the other surface is this green surface, which is known as the curved part. Do you understand this? You have to find out the flux. Wow, looking good. You have to find out the flux of this electric field, because this point charge is going to create electric field. Yes or no? Ding, 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 ding. You have to find out the flux of this electric field that this point charge is creating through that pink portion and through the green portion. I am loving this drawing of mine. Looks good. The pink portion and the green one. 2 minutes we have.
Q by 2 epsilon naught, sir. Sir,
Yes, do we have anything that looks like an answer?
Q by 2 epsilon naught.
Which answer is Q by 2 epsilon naught? Which answer? The pink one or the green one? Huh? The pink one or the green one?
Electric flux of the whole hemisphere.
I asked you pink one and the green one. The question still remains the same. What is the flux through the pink part and what is the flux through the green part? Do it fast. What is the flux through the green part and what is the flux through the pink part? I hope you understand the question. The answer is correct, but which part the answer you are giving me? So that I don't know. That I don't know. So unless I know.
Pink 0, sir.
Pink 0, sir. Pink is 0, sir. That is correct, sir. Pink is 0, sir. What about the green one then? Pink is 0.
Sir,
Understood.
green is Q by 2 epsilon naught.
How did you get green as Q by 2 epsilon naught? That is the next question. Sir, we have some knowledge and we have used that knowledge. But remember, this question that you had to do, you had to only use the knowledge that I have given you right now, not the knowledge that you know beforehand. Are you understanding my knowledge? How did you get Q by 2 epsilon naught? I understand that you have learned something before and that is good. And I appreciate that. How are we going to do this one? So now let us solve it with only the knowledge that I have right now. And the knowledge that I have right now is this gentleman, this Q charge is going to throw electric field lines everywhere. Yes or no? It's going to throw electric field lines everywhere like this. Ding 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 ding.
You into tape point, sir.
But when I look at this pink surface, its electric field lines will go parallel to the surface. Yes or no? And my drawing also looks good. In this case, the electric field lines will go parallel to the surface, and therefore the first answer for the pink part the flux through this part has to be 0. Yes or no?
Yes, sir.
Flux through the pink part is 0. Now comes the curved part. Ding, 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 ding. Now the good part about the curved part is that this point charge q is equidistant from all these points. Yes or no? Is equidistant, and if I draw any electric field will go like this. It will go perpendicular to this, and that is what I wanted to make you understand. It's a very peculiar diagram. Do we understand this? Whenever this electric field line go, I mean, it is crossing this curved surface perpendicularly. Do we understand this, or this has gone above our head saying bye bye sir, ho gaya, aaj ka ho gaya? Do we understand this?
Understood, sir.
So everywhere they are going, the angle is 90 degrees, and the value of electric field at all the points is same. Yes or no? And how much is the value of this electric field? It is K Q by R square. Yes or no? Where R is the radius of the circle, radius of the sphere. Yes or no? Yes or no?
Yes, sir.
This electric field, if I want to find out the flux through this curved path, to find out the flux through this curved path, what I need to do, electric field is 1 by 4 pi epsilon naught Q by R square. I simply multiply it by the surface area of this curved path, which is 2 pi R square, and voila, here I end up with the famous answer Q by 2 epsilon naught. Anyone did it this way? No. Okay. Not a problem. Do you understand how this is done though? Huh?
Yes, sir.
That is what you need to understand, and nothing else. That this is the original way of doing it. Now there is a duplicate way also of doing it. We'll understand that duplicate way also when time comes. We'll understand this. Everyone up till now has got this, yes or no? Okay. Shall I bring forward the next question? Yes or no?
Yes, sir.
Okay. So now we are again just trying to concentrate ourselves on finding out the
Previous page, sir.
what happened? No, previous page. Any problem with this one, beta?
Completed, sir.
Okay. So now what we are going to do is we are going to concentrate on finding out the flux, and we have this gentleman coming up, and this is the best way to understand the flux. So we are going to use this, and I'm loving my diagram these days. I make very sad diagrams, but these are good. Okay, so what is this? Huh? This is a cube. The what? This is your x and y axis. If you have to make this x and y axis, and this is your origin here, and the cube length, the side of the cube is a. Now we are going to do many questions on this. Probably by the end of this class we should be done with this. Let us now, within this cube is going to come many times, let us now try to understand the name of the different faces of the cube. Let me name this cube A, B, C, D, E, F, G, H. How many faces the cube has? Huh?
6.
6. What are the 6 faces of the cube? The first phase is ABCD. Yes or no?
Yes, sir.
Then
EFGH,
EFGH.
BFCG,
Then which one? BF.
CG,
CG, BFCG, okay.
AEDH,
Okay, AEDH,
DHCG,
DHCG, okay.
ABEF.
ABEF, okay. So we are able to identify the 6 faces of the cube. Everyone understand this? These are the 6 faces of the cube. So what we are going to do here is trying to make a general question which we can solve, and that will, okay, I should do this one. Just give me a minute. These are the 6 faces of the cube. Okay, give me a minute. What is happening? I don't understand. 6 faces of the cube. Now we are going to find the flux through these 6 faces in different cases. So I will make a table like this: 1, 2, 3, 4, 5, and 6. And I will give you different electric fields, and you can find the flux through the total, full cube. Remember, this cube is treated as a closed surface. Okay, so let us do this question and let us get the answer. And I will give you different values of electric field. So in one question, we will be doing 5 or 6 or maybe 10 questions. You will understand that the side of this cube is A. The first electric field that I am going to give you, electric field is 4I. Electric field is 4I. Then what is the flux through each phase? And what is the total flux through the entire cube? I'll give you 1 minute to, once you have drawn one cube, that is the only drawing that you have to draw. Once you draw this table, that is the only table that you have to draw. And then you can solve all these questions. Everyone is ready? What is the answer for this one? 4I.
Total is 0, sir.
Total is 0, sir. Okay. I understand. Total is 0. Let me just use a different color pen. Total is 0. What about the others? I was expecting the answer for the phases first. Anyways, what about the flux through ABCD?
0, sir.
0. The second one?
0, sir.
The third one?
Plus 4I, sir.
4A square, not A. Okay, chalo. AEDH?
Minus 4A square.
DHCG?
0, sir.
ABEF?
0, sir.
Okay, good. See, it is simple. Questions are simple. If you understand them, they are pretty simple. Let me now change the electric field. Let me put it as 5J. What is the answer now?
Sir, ABCD 0.
A, B, C, D 0. Okay.
Zero, sir. Next one also.
Next one also 0. Third one,
5A square.
B, F,
Zero, sir.
0, sir. Fourth one also 0, sir.
Zero, sir.
Fifth one,
5A squares.
think again. This is a closed surface. Think again. Take a deep breath and then think and then give me the answer.
Minus 5A square.
Minus 5A square. Its area vector is going downwards and electric field is upwards. So it is incoming flux. Okay. Next one.
5A square.
5A square.
Ah, the total is 0, sir. We understand, sir?
Yes, sir.
Got in the mood, sir? Now,
Sir.
the next one, sir. I've made a big column because this is a three-dimensional field. You are not going to get a three-dimensional field in a JEE, but because it might get too tough. But let us say, if you understand the logic, you should be able to give me the answer. 2i minus 3j plus 4k. This is probably the most difficult question that can come in a JEE. Now, you can also do it by taking the dot product, not a problem. No matter how you do it, you just have to do it. The concern is that you should be able to do it, nothing else. You have 2 minutes to do it. I'll give you time, don't worry. 2 minutes, get me the answer quietly. You can help each other, not a problem. Help each other. You have to help each other. You are friends. Help each other, but get the answer and be satisfied that the answer that you are getting is correct. It's based on logic rather than akkar bakkar bambe bo.
C square, sir. First one.
Everyone got it? Let me just wait for everyone. Let everyone come on the same page. Let's give everyone time. Okay? Time is a luxury that we have right now. So let us use it. Let us get everyone time so that everyone understands, everyone on the same page. Give you 1 more minute because it's a three-dimensional field I've given. That is why I'm giving you 1 more minute. Just because the field is three-dimensional in nature. You just have to see the directions and look at the directions. In which direction what is going, in which direction which is. That is why I started with the most simple one. Only in one direction I gave you the field. So that you get the habit of it and then it becomes easier for you to give the answer. Yes. Shall we? Let's start now. Everyone is ready? Okay. Give me the answer for the first one. A, B, C, D.
Minus 4A square.
Minus 4a square because only the k component will come here. Its area vector is in the plus k direction. So your answer is wrong. It should not be minus 4a square. It should be plus 4a square. Do we understand this?
Yes, sir.
So the second one?
Minus 4A square.
Okay. Remember these things. Okay. Third one?
0.
Take a deep breath. Now give me the answer.
2A square.
Okay. Second one? Fourth one? Minus 2a square.
Minus 3A square.
Take a deep breath. You have to take a deep breath before giving
Plus
it.
3a square.
Plus 3a square minus 3a square and 0. You have to look for the direction of area vector also, beta. Closed surface area vector is outward normal. Don't forget it. You understand this? There is one
Sure.
very peculiar thing that we have seen in all these three cases. Yes or no?
Total electric field is 0.
Total electric field is 0. Total flux is 0. Okay. Total flux is 0. Don't forget that. There's not total field is 0, but total flux is 0. Let me now change the question and the electric field now becomes the black one. Electric field is Xi. What is X? X is the distance along X-axis. So what type of electric field now we have? Do we have a constant electric field or do we have a variable electric field? Huh?
Variable. Variable, sir.
Now we have a variable electric field. Again, you have the 6 phases. God bless you. I will just write it above because let me just make a column here so that I get space. Electric field is Xi hat. You have 2 minutes. Take a deep breath, get the answer, and stay happy.
It's 0.
What?
ABCD is 0, sir.
Give 4. I want all the answers. Are you ready with all the answers? We'll only listen to all the answers together. Then only it makes sense. So please get all your answers ready before jumping on to answers. Get all your answers ready. That's why I given you 2 minutes. So that you can get all your answers, everyone, all your answers, because the next field is going to be the most difficult one ever. So I want. Okay.
0, 0, xa square minus xa square, 0, 0.
0.
Okay. Everyone is giving me answers, but no one is giving me the correct answer apart from zeros. Apart from zeros, all the answers are not correct. Only the 0 wal answer is correct. Think about it again once more. You have time, don't worry. Make the best use of the time that you're getting, my dear friends. One more minute is left. Everyone is ready with their answers? Huh? Yes or no? No or yes? 15 seconds.
Third one and fourth one, sir.
Third one and fourth one, sir. Everyone got the answer, sir? So let me now give you my
X square a square by 2 minus x square a square by 2.
Take a deep breath. Have patience. Okay, A, B, C, D. A, B, C, D is along Z axis. So we say bye bye to this. We say bye bye to this. D, H, C, G. We say bye bye to this. We say bye bye to this. The only 2 people that we are concerned about is this face and this face. Do we understand this? Yes?
Yes,
Or
sir.
no? Now remember the magic of this X. Magic of this X. For this phase, which is the pink phase, what is the value of X? What is the value of X?
X square A square by 2, sir.
The value of X is 0. And therefore the answer is 0. Yes or no? Do we understand this, or it has gone above our head saying bye bye, sir?
Understood, sir.
No, sir.
This is my cube, my dear friends. This cube is kept like this. This is my origin here, here is my origin. You see, here is my origin. Tick, 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 tick. What is the value of X for this one? You understand my cube? Your origin is here. And this is your surface, AEDH. Do you understand this surface?
Yes, sir.
What is the value of X for this surface? It is constant. X does not change. It is 0. Electric field is 0. If the electric field is 0, how will the flux come? So the answer is 0.
0.
Do you understand this?
Yes, sir.
Yes, sir.
Then you have the other phase to deal with, DHCG. DHCG, yes. What is the flux through DHCG? DHCG nahi. Which one I've written? I've written wrong. I mean, this should not be 0. The niche wala is 0. AEDH, sorry. I just wrote it upar niche. Now, what we are remaining is BFCG. What is the flux through the surface BFCG or BFGC, whatever it is? Should be BFGC. What is the flux through BFGC? Yes.
X square A square by 2, sir.
Huh? X square, A square by 2, anything.
X
Easy.
square.
Remember, imagine this cube. This is the cube that we are talking about. X is 0 here. Ding, 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 ding. What is the value of X here? It is A. And this X is constant. It does not vary. If it does not vary, electric field is constant. It does not vary. The value of electric field is A into I. It does not vary. A into I. It does not vary. And the area is A square into I. Vector wise. You take the dot product and you get A cube. And that is the answer for this one. A cubed. Do you understand this? Even though this is a variable electric field, the two phases that we are concerned, on those two phases, electric field does not change. And therefore the answer remains a constant electric field. But since the electric field is variable, overall what you see is your answer is not 0 now, it is plus A cube. Do we understand it, or this has gone above what I'm saying bye bye, sir? It's gone. Imagine this cube. Everyone is imagining the cube, yes or no?
Yes, sir.
You understand this, sir? It has gone above our head, sir. Saying bye bye, sir. Huh? You understand this or no?
Understood, sir.
Then comes the most difficult one. And let's see if you can do this one. Now remember how the electric field is going to vary now. The electric field will vary in a very fancy way. You are not expected to solve this question, but I can try it. Try to succeed sometimes. So this comes the red one, danger
Sir,
one. Yes.
once explain A cube, sir.
Electric field is constant, sir. At this point, for this surface, the value of x is A. X does not change, only Y changes, but that doesn't make any difference to the electric field. Electric field only depends on the value of X. X is constant. Yes or no? Do we understand this? The value of X does not change. So electric field does not change for this surface. It is same. Any doubt? What you have not understood? Tell me that. Tell me that point.
Understood, sir.
Electric field varies with X. If X changes, electric field changes. At this surface, electric field is 0, my dear friend. At this surface, electric field is equal to A. It changes from O to C along the x-axis. But on the face, BFGC phase, this green phase, electric field does not change because the value of X for all these points is same. Do we understand this? This phase is exactly similar to the pink phase. In the pink phase, the value of X was same for all, it was 0. Here, the value of X is same for all, but it is A. So electric field is constant. You understand this? Yes or no?
Yes, sir.
That means that this next one is going to give you another round of trouble, and that is one yi plus xj. Now I made a field which is just too good to be true, too difficult to make, but I can write it and make it. Yi plus xj. So the component along x-axis varies with y, and the component along y-axis varies with x. I hope you understand what is written there. Yes or no? Now again, you might not encounter such field. If you understood the concept, just to make you understand what variable field is and how this variable field can create flux, that is the only reason this question is given to you. Yes. Does anyone has the answer to this one? Two faces are still going to be 0. Which are the two faces which are still going to be 0? Yes. Everyone knows those faces.
First two, sir.
First two are definitely going to be 0. Now this question becomes, you are not supposed to get both the fields together. You will only get one of these. Either you will get the X wala field or the Y wala field. I put them together so that you just confuse yourself and nothing else. Now, how do I solve this? For this I wala field, I only need this I wala field will only come with the surfaces who are along x-axis. And what are those surfaces which are along x-axis? Our friendly neighbor green surface and our friendly neighbor green surface and our friendly neighbor pink surface. Yes or no? These are the two only surface which will come with this I wala thing. Yes or no? Yes,
Sir.
or no?
Yes,
Sir.
sir.
Okay. Now the problem is the field is variable. The field is along I, that's the direction. Now it varies along Y. Yes or no? Yes or no?
Yes, sir.
So now you will have to use the technique of integration. So you go here at a distance y, then you take a small segment of dy. You can find out the flux through this small segment. What will be the flux through this small segment? What will be the flux through this small segment? The area of this small segment is, let me write it here. The area of this small segment is A into dy, yes or no? Yes or no? Yes or no?
Yes, sir.
And the value of electric field is y. So I multiply this by y. So the small flux is A into y into dy. The total flux will be the integral of this from 0 to A. That is your answer. This field is along I. This area vector is along minus I. So the answer would be negative, and your answer would be minus a cube by 2. Do we understand this? Yes or no? We understand this?
Yes, sir.
This is the answer for the pink surface. What is the answer for the green surface? Now remember, when I come on the green surface, the condition actually remains same, because the electric field does not vary with x, it only varies with y. So whatever I have done for the first surface, the same thing I have to do for the second surface. The same answer I will get for the second surface. The only thing is this was minus I and this is plus I. So the answer becomes plus a cube by 2. You understand this? Try to understand
sir.
why we have to use integration, because now the surface is vertical. See this vertical, this surface is vertical and your y is varying along the vertical, and that is why I have to use the technique of integration. Do we understand this? Do we
Yes,
understand
sir.
it? Now let us move on to the J wala surface, blue surface, J wala surface, which is the surface having their vectors along this one J1 and this one niche wala one. For one it will be positive, for the other one it will be negative, right? Now for this J wala surface, electric field is varying along x. Electric field is varying along x. So how I need to do it? I have to move like this. Distance x, then the small strip dx. The only difference that it will make is, now the electric field is x. The area of this segment is A into dx. Let me write it here. The area of this segment is A into dx, and the electric field is equal to x. I put the integral of it from 0 to A. The same answer will come, which I got in the previous cases. But now, one will be positive, the other one will be negative. The upper wala one is positive, so I write plus a cube by 2 here. This is negative. Coincidentally, my total flux is also coming as 0 because of the way the problem was. Otherwise, the answer would have been different. Do we understand this? How this is done?
Yes, sir.
Yes or no? We get this? This is just to make you understand when is the field variable and when is the field constant. Even if the field is variable, the area, for that area, it may be constant. It may be constant. See, the best example of this one is here. See, this electric field that I draw is also actually a variable field because it is having different directions. Yes or no? But for this particular surface, the answer was very simple because it was perpendicular. Do we understand the relevance between this one and that one?
Yes,
This
sir.
electric field is also variable. If the surface would have been different, if the surface would have been like this, the answer would have been drastically different. But since the surface was also curved, this becomes simple. Similarly, in the previous case, even though the electric field was variable, the answer was simple and simple because of the surfaces were simple. Do we understand this? With this, we come to an end of one part of your electric flux. Life goes on. We have still not started your favorite Gauss law, but that is how it is done. We'll first have to finish with the flux part. Then only we can come on to the Gauss law part, which we'll do in the next class, that is tomorrow. Take care and God bless you all. Bye bye.